So it says a box is pulled by a string, horizontal string, at a constant speed across a horizontal surface. Draw a free body diagram and write out an F-net equation. You can do this, right? For sure you can. We've been doing this for a while. What's one of the forces acting on that box? Gravity. It's the force of the Earth. On box. Fg. One down, a few to go. What else you got? Force of the string on the box. Where does that one go? To the right. Does it have to be to the right? Or the left? It doesn't really matter. We'll say right because that just seems normal to us. Or not normal, but like natural. Yeah, we can use that right there. String on the box. F tension. Is that okay? Awesome. Two down, more to go. Yeah. Normal force. Which way does that one go? Straight up. Because it is what to the surface? Perpendicular, they say with enthusiasm. F of the table or the whatever surface it is on the box. Fn. Anything else acting? Milo's shaking his head. Why are you shaking your head?
There's the force of the surface on the box, the force of friction.
Oh, how do you know there's a force of friction?
It's at a constant speed. It's not even accelerating.
It's not even accelerating. It's not even accelerating. So there's got to be another force back here. The force of the surface on the box. That force of friction. How are we doing? Anybody 4 for 4? Got all those forces drawn on your diagram? Yeah? Put your hand in the air. Be proud of yourself. Yay for you. Oh my gosh, I didn't see a lot of hands though. So I'm hoping this is making sense. We're going to write down some F-net equations. F-net in the X, F-net in the Y. Let's do F-net in the X direction. What forces are acting in the X direction, my friends? Somebody I haven't talked to yet. Something acting in the X, yeah. The force of friction is acting in the X direction. In the positive or negative X direction? Negative, because you decided that we're going to make left negative. Fair enough. Anything else acting in the X direction? Somebody else I haven't talked to yet today. Engage with this, you guys. We got to go, go, go. Damani, is there another force acting in the X direction? Yeah, the force of tension. Is that one positive or negative? How do you know? Because it's to the right? I couldn't hear what you said there, Don.
I don't know.
It's to the right, and somebody else decided that left was going to be negative and told us that because of the friction force. Does that make sense? You could call that positive if you wanted, but we've already decided that the force of friction is negative. The tension is going in the opposite direction. That's the key there. F net equals ma. Is it accelerating? It is not. Okay. I'm going to give you 30 seconds to write down that F net equation in the Y if you haven't already. If you have, check with your table mates. I want it to be loud physics talk right now. Go.
That's negative FG equals 0. That's one thing. I don't know how we find the dumb physics, so the Swedish one is so it's basically like a really
All right, I want to share the physics love. If you've already told me something today, you're off the hook for a moment. Help me out. Somebody who hasn't said something yet. We're writing down F net in the Y direction. What's one of the forces acting in the Y direction? Lots of you know it. Have you told me something yesterday?
I think so.
Okay, go then.
Force of gravity.
The force of gravity. Is that going to be positive or negative? It is. Okay. Anything else acting in the X direction or in the Y direction? Excuse me. Yeah. Max, you've already told me something today, haven't you? Really? Okay, go ahead. I thought you had, but I'm wrong. What's that? Normal force. Is that one in the positive or